Our last application in this section is surface area. And our formula for surface area, if we rotate about the x-axis, is the integral from alpha to beta of 2 pi r, our radius is the height, the y, times the ds. And ds we saw from the arc length before is the square root of the derivative of x with respect to t squared plus the derivative of y with respect to t squared dt. So, as an example, we want to find the surface area of the shape. X equals r cosine t, y equals r sine t. If you recognize this formula, this is a circle with radius r. You will notice also it starts at this point r0 and then rotates around like so. It's important to point out that our integral is going to go from 0 to pi. If we go from 0 to 2 pi, what's going to happen is we're going to end up with double the surface area because the top part will sweep out the whole thing, and then the bottom part will also sweep out that same area. So if we've got a shape that's symmetric like this with respect to the x-axis, that is the axis that we are rotating it about, we need to be careful to just take the top half, or else we'll end up with double the answer that we want. So s equals the integral from 0 to pi of 2 pi r. In this case, r is r sine t times the square root of dx dt is negative r sine t squared plus dy dt is r cosine t squared dt. Looking at the square root, we notice we can simplify what's inside of the square root. It's going to be r squared sine squared plus r squared cosine squared. Factoring out the r squared, we would end up with r squared times sine squared plus cosine squared, which we know is Pythagorean theorem. That is 1. So our integral becomes, notice also that r is a constant. We're going to factor out 2 pi r. We have sine t times the square root of r squared dt. Since the square root of r squared is r, we can also factor out that r as well. So now we have 2 pi r squared. The integral of sine t dt is negative cosine t, and we're integrating from 0 to pi. So evaluating this at pi, the cosine of pi is negative 1, and then minus negative here. The cosine of 0 is positive 1. So it looks like we have 2 pi r squared times 2, which is 4 pi r squared. And you will recognize that as the surface area of a sphere. Thinking about the shape that we're dealing with a circle. We're rotating that circle about the x-axis. That ends up giving us a sphere. And that's the end of calculus with parametric curves.